Hello everyone, welcome back. I'm very happy with the overwhelming response that you gave for the previous video, and I had promised, I know, that if I cross 100 subscribers I would be posting the next video. And I hope you had liked the previous video and you had shared it with your friends and all, and I want you to do the same thing for this video. Come on, I don't want any excuse. Like it right now, like the video right now, and then only we'll proceed. And share it with your friends, obviously. And if you have not subscribed yet, please do that. Please subscribe to this channel and press that bell icon right now. I said right now. I said right now. Yes, that's more like it. Now let's proceed. Now I know I told in the previous video that we'll be covering all the concepts and numericals pertaining to school exams, board exams, and entrance exams, and so on and so forth. And we already know that NCERT is inevitable for all of these. So I've decided that I will be covering the NCERT textbook first. Don't worry. After this, we'll be doing a summary of the entire chapter and also many numericals. So many numericals that you will be ready for even advanced or difficult questions. That doesn't mean you will not be able to solve easy questions as well. Okay, so I'll be making you ready for everything. So let's start off with the NCERT. Now I'll be reading along, so I would recommend that you take out your NCERT textbook and you read along with me and underline the important points. Okay, so starting with chapter number 1, electric charges and fields. Introduction. All of us have the experience of seeing a spark or hearing a crackle when we take off our synthetic clothes or sweater, particularly in dry weather. This is almost inevitable with ladies' garments like polyester sari. Have you ever tried to find any explanation for this phenomenon? Now, till this, what do we understand? That we see a spark or hear a crackle when we take off synthetic clothes or even polyester sari. So we understand that it is a property which is accompanied with these material, and it is more evident in dry weather. It is underlined over here that it is more evident in dry weather. Now why is this? Okay, have you ever tried to find any explanation for this phenomenon? Now I would be giving the explanation for this phenomenon. This is called frictional electricity, or it is also called static electricity, as you can see here. Static electricity underlined over there. Now what is happening in this? If you go into molecular level or atomic level, you know that there is a nucleus in the center of the atom. Yeah, you know the nucleus, inside the nucleus there are neutrons and protons and all those things. But our important thing over here is electrons which are revolving around it. We know that electrons are revolving in different orbits, and there are some electrons which are far away from the nucleus. Right? They are called valence electrons. The electrons which are at the outermost orbit or shell. They are the valence electrons. So what happens is, if these valence electrons get some amount of energy, already it is very in a high level, it has a high level of energy, and if you give by some mode an energy to it, then what will happen? It will get enough energy to escape from the atom, to jump out of the atom, to get knocked out of the atom. Right? So that is what is happening over here. So when you wear these kind of material, usually you are in constant motion. Right? You are in constant motion and you are rubbing here and there. You sit somewhere, so your cloth is rubbing on the surface. So because of this friction, the electrons get enough energy to get knocked off. Just think about it. If you rub your hand feels hot after some time. So what is happening? Due to friction, there is a transfer of heat energy. So same thing happens with these material. When they are constantly rubbing against different surfaces, it gets enough energy so that electrons jump from either surface to the other. Sometimes the electrons may jump from your cloth to the surface where it is rubbed against, or the electrons may jump from the surface where you are rubbing against to your cloth. Okay, so in either of the cases, your cloth is getting positive or negative charge. In each case, I'll explain. If electrons jumps from your clothes to the surface where it is rubbing against, then you lose electrons or you become positively charged. And again, if electrons are jumping from the surface where you are rubbing against onto your cloth, then you are gaining some electrons, so you will become negatively charged. Now, but this sparkle and all, this spark and this crackle, spark and this crackle that you hear is not due to formation of these charges or accumulation of these charges. It is due to discharge. That is, these charges which have accumulated on your clothes gets discharged. How? Okay, when you are removing the cloth, or in these cases, it conducts through your body, because your body is a very good conductor. Your body is a very good conductor, so because of which these charges get discharged through you to the ground. So that's how you hear this spark or crackle. Now, why do you hear this particularly in dry weather? Because air is a poor conductor of electricity, or air is a poor conductor of these charges, especially when it is dry. If it is wet, water is a good conductor, so the water content in the air, it takes away these charges. Okay, if it's positive, if your cloth is positively charged, it gives you electrons and neutralizes this. But if your cloth is negatively charged, it takes away these electrons and neutralize this material. So that spark or crackle won't be heard if it is a wet weather. Okay, I hope it is clear. Now let's proceed. Another example, another common example of electric discharge is the lightning. So yes, we have already discussed that this is an electric discharge. Another example of electric discharge is lightning. So what is happening in lightning? So when there is thunderstorm, air is in constant motion. So again, friction comes into act. So due to friction, what is happening is the clouds, they become charged. The positive charge accumulates on the top surface of the clouds, and negative charge accumulates on the bottom surface, on the lower surface of the clouds. Now we know, I have told already that air is a poor conductor. So these charges cannot be discharged to the ground. No one is touching the cloud and there is no body to conduct the charges. Then how does the discharge happen? Because lightning is the discharge. Two reasons. One is water is a good conductor, I have already told, and it's raining. So that's one reason. Another reason is the potential. We will learn what is potential and all in the coming sections. The potential, or you can say the amount of charge stored in the clouds are so high or so huge that the air becomes conductor. Air is forced to conduct. It's like if you take store water in a balloon, what will happen? It will burst finally. That same phenomenon happens here. The clouds, they store so much charge that charges leak. Charges leak through the air and it goes to the ground, and that is the discharge, and that is the lightning that we see, and that's the sound, the thunder. It's all same phenomenon. So it's like your cloth behaves like a cloud and it discharges the charges to the ground. Similar funda. Anyway, so now let's read on. We also experience a sensation of an electric shock either while opening the door of a car or holding the iron bar of a bus after sliding from our seat. Now again, note the point, after sliding from our seat. Why is that sliding of seat so important? Sliding through the seat so important? You are sitting in a seat. Now when you are getting up, your cloth rubs against the seat. So again, who comes into action? Friction. So because of friction, yes, the same thing happens. The charges either jump from your cloth to the seat, that is electrons, or electrons jump from the seat onto your cloth, and so your cloth becomes charged. Now when you hold the iron rod, or you try to open the door of a car, then what happens? The charges accumulated, it gets a path to discharge, and it discharges through the car onto the ground. Got it? So I hope this is clear. So frictional electricity, if someone asks you what is frictional electricity, just tell them, Fawaz sir taught us that and I know it. Okay. Now let's proceed. You might have also heard, where is it? Okay, the reason for these experiences is, now they are saying it, is the discharge of electric charges through our body which were accumulated due to rubbing of insulating surfaces. Now here another thing you have to notice is insulating surface. I told if it's a conducting surface, what will happen? The charges will not stay there. It will be conducted away. It will be discharged. While charging itself, it will get discharged. So it won't stay there. It will not accumulate enough to form a spark or to hear a crackle. Okay, so insulating surface is very, very important. If you want to do the same thing with the conductor, you have to have an insulating support so that it does not leak. Let's continue. You might have also heard that this is due to generation of static electricity. Yeah, you have heard it from me already. This is precisely the topic that we are going to discuss in this and the next chapter. Yes, there are two chapters which deals with electrostatics. Okay, that's what is written over here. Static means anything that does not move or change with time. Yeah, static, you have learnt in mechanics in grade 11. Static, you're studying about bodies at rest, and here what is the body that you're talking about? You're talking about charges. So here charges are at rest, but you said charges move from one body to another. Yeah, it just jumps from one body to another and after that it stays there. So the charges which are at rest on our body, that's what we are going to learn. Or not only on our body, any charge which is at rest, that's what we're going to learn in this chapter and the next. Now what is the definition of electrostatics? Electrostatics deals with the study of forces, fields and potentials arising from static charges, or it is the study of charges at rest. Okay, so we'll learn about field, potential, force and all in the coming sections. So that's all for now. I had promised that I'll make short and sweet videos, so this is short enough and I hope it is sweet enough also. So I remind you, if it is sweet enough, press that bell icon, press that subscribe button, press that like button and make me happy. Okay, and also don't forget to let me know the feedback in the comment section. Let me know if I'm making any changes to your understanding of physics and if you're liking it. And will you promote it? Will you promote this channel to your friends? Will you let them know? Let them also enjoy the wonderful world of physics. So until we meet again, it's goodbye from me and happy physicsing.